Okay guys, this one's going to be a lengthy one. It is mid-segments. We're going to take this triangle right here, JKL, and show the mid-segment MN, which should be right around here, is parallel to JL, and that it is half the length of JL. So that's what there is about a mid-segment that we need to know. And we have steps 1, 2, and 3 is the overview. First is the mid-segments, which we're finding the midpoints. Then we'll find the slopes. We'll do it by counting. And then we'll take the mid-segment and then this, and we'll use the distance formula to find out how long they are and to show that the MN happens to be half the length of JL. So let's get started. Okay, the mid-segments of JL. Okay, these are the ordered pairs for the JK. These are the ordered pairs for the JK. This is the formula. It's add the x's, which is -6 and -2. And divide by 2, and then add the y's, 1 and 5, and divide by 2. So what I have here is -8 divided by 2, and 6 divided by 2, which becomes -4, 3. So my M is -4, 3. So 1, 2, 3, 4, 1, 2, 3, and that looks like the mid-segment. So we're in good shape there. Now the KL's mid-segment, these are the ordered pairs. I got them from right here. And the x's are -2 and 2 divided by 2, and the y's are 5 and -1 divided by 2. So here I have 0 over 2 and 4 over 2. So that leaves me with 0, 2. So the ordered pair for this second one is 0, 1, 2. Looks like the middle to me, and we'll call him N. All right, so we want to keep those in mind. We will have to use them again. Let's connect M and N. That is my mid-segment. Now, the thing about a mid-segment is that it will be parallel to this JK, and it will be half the length of JK. So let's get the parallel proved. Using the slope formula, you can use the slope formula, but if I have it graphed, I will just count it. You start at the bottom one, and you rise up to get even to the top one. So I'm rising 1, and I am running 1, 2, 3, 4. So the slope of MN is 1/4. The slope of JL needs to be 1/4 too if they're parallel. Let's see. We're rising 1, 2, and we're running 1, 2, 3, 4, 5, 6, 7, 8. And 2 over 8 reduces to 1/4. So I do know that MN is parallel to segment JL, and I've proved it with the slopes. Now, for the last part, the distance formula, here it is, and I made the templates. The templates are helpful because you don't forget there are minuses in the problem. So I made the templates. Now the MN ordered pairs that I'm using will be, let's see, where were those? These two right here. So I'm using -4, 3, and 0, 2. It's those ordered pairs right there. So x2 and x1 is 0 and -4. And y2 and y1 is 2 and 3. So I add the opposite here, and I end up with 4 squared, plus add the opposite here, end up with -1 squared. Now remember, if you get a negative, it has to be in parentheses. All right, the square root of 4 squared is 16 plus 1, which is the square root of 17. Okay, let's leave it in that form right now. Now the JL ordered pairs, they just came from up here, is the x2 and x1 is 2 and a -6, and y2 and y1 is -1 and 1. So when I add the opposite here, I end up with 8 squared, and then -1 minus 1 is -2, -2 squared. So 8 squared is 64, plus -2 squared, a -2 times -2 is a 4. So I end up with a square root of 68. All right, so let's see what we have here. The square root of 68 is approximately 8.246. The square root of 17 is approximately 4.123. And let's take that 8.246 and divide it by 2. Yep, 4.123, rounded off a little bit, but we do see that what they wanted me to prove, MN is half of JL.